In the quest to explore the universe, the Hubble Space Telescope. No scientific instrument in history has revealed so much or taken us so far. Perched above the distorting veil of Earth's atmosphere, Hubble sees what we cannot. Using vivid color to represent scientific data, Hubble paints pictures of unprecedented clarity. Pictures that bridge the domains of art and science and form a direct link between the most powerful forces in nature and the human spirit. For most of human history, the night sky was something you looked at. A jewel-studded canopy that stretched from horizon to horizon. To our ancestors, this perspective offered no hint of the universe's true depth. Wherever they looked, the stars seemed equally remote, like glowing dots painted on a distant ceiling. After the invention of the telescope, humanity experienced a shift in cosmic perspective. The shift was gradual, but it was profound. The more the telescope revealed, the more obvious it became that the universe has a third dimension. Now we understand that when we're looking at the sky, we're really looking into space. The Hubble Space Telescope is ideal for plumbing the depths of the universe's third dimension. From its lofty perch high above Earth's atmosphere, it can see both nearby and distant objects with unwavering clarity. Its many spectacular images form a visual pathway that leads us from the boundaries of our own planet to the most distant corners of the cosmos. That pathway begins with one small step to a rocky satellite that is large enough to be considered Earth's sister world. Compared to our lush and watery home, the dry, barren moon hardly seems like a close relative. But the differences are deceiving. The Earth and Moon share a common origin. By exploring the Moon's ancient surface, scientists can uncover secrets about our own planet's remote past. The Moon also functions as a giant mirror that reflects sunlight in our direction. Because Hubble's sensitive optics would be damaged by looking at the sun directly, astronomers have pointed Hubble toward the Moon to measure the colors in the sun's reflected light. At the same time, they opened up Hubble's cameras for a close-up view of our nearest neighbor in space. Because the Moon and Hubble are moving so quickly relative to each other, the Moon is one of the most difficult targets for the Space Telescope to capture. A short leap from the Moon takes us further into the inner solar system for a false color look at the atmosphere of Venus. Venus is a planetary inferno, where a surface that is hot enough to melt lead is cloaked in dense clouds of sulfuric acid. In contrast, Mars is a rust-colored desert where liquid water may still trickle beneath the surface, and where someday the past traces of microscopic alien life may yet be found. Past the orbit of Mars lies the outer solar system, the realm of the gas giant planets, beginning with Jupiter, the largest of them all. Jupiter is not a solid world, but a vast globe of liquid hydrogen and helium, more than 300 times the size of Earth. With astounding clarity, Hubble offers us an ever-changing view of Jupiter's swirling, multicolored atmosphere. Hubble carries us to the frozen fringe of our solar system, home to the dwarf planet Pluto and its large moon, Charon. Pluto is so far away, it has yet to be visited by a planetary probe. But in 2005, astronomers using the Hubble discovered that Pluto also has two smaller moons, now called Nix and Hydra. This discovery was used to construct an artist's impression of what it might be like to stand on Pluto's surface, where hills tinged by nitrogen frost are illuminated by the light of three moons. At such extreme distances from the Sun, there is very little light available to reveal what lies after Pluto. But Hubble's penetrating eye has revealed an entire population of tiny worlds lurking in an endless night. This is Hubble's best glimpse of Eris, an icy world that is larger than Pluto, but more than twice as distant. If we could look homeward from Eris, we would find that Earth is already too faint to see, and the Sun is merely the brightest star among many others. Now the true expanse of our three-dimensional universe begins to sink in. As we journey deeper, crossing the great ocean of interstellar space, we discover that our solar system is part of something 1 million times larger. A great starry metropolis called the Milky Way galaxy. With stars numbering in the hundreds of billions, our galaxy includes nearly everything our ancient ancestors could see in the night sky, and much, much more. Compared to our Sun, some of the stars we find in the Milky Way are luminous giants, nested in thick clouds of gas and dust where they only recently formed. In one such cloud, so far away its light would take 8,000 years to reach us, we find what appears to be one of the largest stars in the galaxy. That is, until the Hubble discovered it is really two stars in one, each more than 100 times the mass of our Sun. At the other extreme, Hubble spies a red dwarf star, so small and dim it will shine for 1 trillion years, throwing its crimson light onto an even smaller companion. This smaller object is believed to be a brown dwarf. a tiny ball of gas that is halfway between being a planet and a star. Brown dwarfs were first hypothesized years ago when they were too faint to be seen from Earth. Among Hubble's most important achievements is the confirmation that brown dwarfs exist in great numbers throughout our galaxy. Some stars are not solitary, but are congregated into giant globular clusters. Like a swarm of glowing fireflies, the star cluster known as M80 captures Hubble's roving eye. It was by carefully measuring the distances and distribution of globular clusters like this that astronomers first discovered the true dimensions of our Milky Way. We now know it is a great spiral system, a whirling disk of stars, gas, and dust so huge it takes light 100,000 years to cross it. But just as the solar system was our stepping stone to a much larger reality, so in turn, the entire Milky Way gives way to the unimaginably vast universe that lies beyond. This is the universe our ancestors, with their two-dimensional perspective of the night sky, could not perceive. A universe populated by galaxies in the tens of billions, as magnificent as they are diverse. It is when Hubble looks out at these faraway galaxies that we begin to appreciate the true scale of our cosmic perspective. For in the background, behind each great galaxy, Hubble reveals not emptiness, but an endless corridor showing more and more galaxies stretching back to the limits of our perception. Today, astronomers estimate that Hubble can peer more than 13 billion light-years into the cosmos. In such a large volume of space, the possibilities for discovery are staggering. Hubble has not taken us to the end point of our cosmic perspective, but rather to the beginning of a new era of exploration, an era in which the deeper we look, the more we see. The domain of the telescope is the domain of space. And in a universe like ours, there's plenty of space to go around. Because it can look so deeply into space, the Hubble Space Telescope also brings an added dimension to our view of the cosmos: the dimension of time. The light that reaches us from the far corners of the universe takes millions, even billions of years to cross the great expanse of intergalactic space. That means the light we see today departed from its source long ago in the ancient past. We can never see the universe the way it is, only the way it was. Over short distances, this effect is slight. Objects in our solar system are so near that their light reaches us with a delay of only minutes or hours. At such close range, Hubble can easily track dynamic changes as they occur. Here it captures a comet in the act of breaking up. Comets spend most of their time at the frigid outskirts of our solar system. As they dash past the sun, the change in temperature puts the comet's icy nucleus under extreme stress. In this case, the result is total disintegration. In 1992, comet Shoemaker-Levy 9 went through a similar breakup after making a close pass of the planet Jupiter. 2 years later, the train of comet fragments circled back, one by one plowing into Jupiter's atmosphere in a series of spectacular collisions. In this ultraviolet view of Jupiter, taken during the week of the collision, the vivid swirling features of Jupiter's atmosphere are muted. Much more obvious is this small dark spot, which is actually the shadow cast by Io, a moon in orbit around Jupiter. But across the planet's southern hemisphere, Hubble shows a line of dark patches formed as the fragments of comet Shoemaker-Levy 9 collided with the rotating planet one after another. The patches are dark because the dust that the collisions deposited in Jupiter's upper atmosphere absorbs ultraviolet light. In the days and weeks that followed, the dust became a marker that allowed scientists to track the winds in Jupiter's stratosphere. Beyond our solar system, we no longer see the universe in the here and now. Many of the stars and glowing clouds of gas revealed by Hubble are thousands of light years away from us, which means we see them as they were thousands of years in the past. But even at these distances, there is ample evidence of dynamic change through time. This awe-inspiring Hubble image is the best picture ever taken of the Cone Nebula. It is a cold, dark pillar of hydrogen gas and dust with a glowing top. The glow is caused by ultraviolet light from a brilliant star located just above the edge of the Hubble picture. The light is steadily pushing on the top of the cloud, creating a shadow effect underneath. In time, this pillar will be eaten away by the light, possibly revealing a nest of newborn stars. Because we are seeing this nebula as it appeared in the past, it has already gone through many changes that we have yet to witness. These changes are advancing on the scale of thousands of years, too slowly for Hubble to track. But Hubble can travel in time in a different way, by looking at clusters of young stars that formed millions of years ago out of clouds of dust and gas similar to the Cone Nebula. Looking across larger stretches of space, Hubble's canvas also encompasses longer epochs of time. Here, two galaxies careen past each other in a near collision. The smaller of the pair is the size of our own Milky Way galaxy. As it swings by its larger neighbor, gravity distorts the small galaxy, stretching out one of its spiral arms. galaxies, nicknamed the Mice, a collision in progress has flung two long tails of stars far outside the galaxies where they were born. The Mice are now moving apart after a close encounter 160 million years ago. Eventually, gravity will halt their separation and they will fall back together into a grand merger of all their stars. In another region of space, we can see the same story carried forward to the next stage. These are the antenna galaxies, now 900 million years into a spectacular collision and more than halfway to a total merger. Here, Hubble offers us the best view yet of the heart of this astounding interaction. While the stars of the antenna galaxies are free to fly past each other at high speed, we find that something different has happened to all the dust and gas the galaxies carry with them. Gravity has pulled on this material, and now we see it spilling out into the space between the two galaxies, where it's ushered in a baby boom of star formation. Hubble's view shows a glowing network of bright pink nebulosity. It's the telltale color of glowing hydrogen gas. It highlights the nurseries where new stars are being born. In their midst, we also see brand new star clusters full of hot blue stars that have recently ignited. But while these dramatic views show us time unfolding in the universe around us, they portray a universe that is fundamentally identical to the here and now. Even though Hubble is peering into the past, when it captures the light from these bright galaxies, it's only probing the recent history of our universe. But glimmering in the background, we can find hints of a deeper time when the universe looked very different than it does now. In the constellation Draco the Dragon, Hubble comes across a gorgeous spiral galaxy. Its light took 80 million years to reach us, and it looks very much like the Milky Way, the galaxy we call home. But more than 10 times farther away, Hubble also spots a quasar. This object is part of a galaxy too, one that's too faint to show up in this picture, except for its center, which is shining far brighter than any normal galaxy would appear at such an extreme distance. Quasars are inhabitants of an earlier period in the universe's history, when giant black holes at the centers of young galaxies powered brilliant eruptions of energy. Here, Hubble operates as a time machine, allowing us to witness a long-vanished age. The same strategy has been used to capture Hubble's deepest view of the universe to date. It was created by pointing the Hubble at an empty patch of sky again and again over a 5-month period. At first, there was nothing to see here at all. No stars within our Milky Way, no bright galaxies beyond the Milky Way's borders. But gradually, an image began to emerge. The image of thousands of galaxies at the very limits of our cosmic horizon, going back more than 10 billion years into the past. Like a living fossil, the image reveals what the universe looked like shortly after the Big Bang, when star formation began and galaxies were brand new. As we explore these far-off islands of light, distant from us in space and time, It's clear that the galaxies of this era are not the stately spirals and other forms that are familiar to us today. These galaxies are smaller, dustier, and more disturbed. They are the products of a cosmic construction project in which gravity builds bigger galaxies out of smaller constituents. Until now, astronomers have only been able to guess at how the universe as we know it came to be. Now, thanks to the Hubble, we can watch the process in action, touring from past to present. With Hubble as our looking glass, time is a landscape that stretches before our eyes, and a journey that is just beginning.